Hello, welcome to Taxonomy Online Mathematics. We are still on application of differentiation. And in this episode, we want to start a tutorial on the rate of change. When we talk of the rate of change and differentiation, what does it mean? So when we take a quantity y, which varies with respect to x, so any quantity, k varies with respect to m. If that is happening, then the rate of change of y with respect to the x is given by the dy dx. So if it is the quantity p and r, it will be dp dr. So y is increasing or decreasing with respect to x accordingly as dy dx is positive or negative. So when the dy dx is positive, it means y is increasing with respect to x. If it is negative, it means y is decreasing with respect to x. That's the rate of change. So the rate of change of p with respect to time is given by the dp dt, the rate of change of any variable with respect to time. The time at which that variable is changing will be the dp, the differentiation of that variable with respect to what? T. So the rate of change can be related by the chain rule. Remember the tutorial we have on chain rule. So the rate of change can be associated or related with what? The chain rule. So for example, if the sphere with a volume V and a radius of what? R is given. For example, the volume of a sphere is given, whereby the volume is in terms of what? R, which is the radius. Then the rate at which the volume is changing with time, the rate at which the volume is changing with respect to time will be equals to the rate at which the volume is changing with respect to the radius. The volume with respect to radius times the rate at which the radius is also changing with respect to time, where the v, which is the volume, will be a function of r. If it is the function of r, then the v dr. Then r is also in a function of t, which is dr dt. That explains the chain rule property. So this is what we'll be using in rate of change. So for example, the radius of a circle increases at a rate of 0.2 centimeter per second. Centimeter per second. That's what dr dt. You see the per second there. Find the rate of change in the area of the circle of radius 4 centimeter. So you're looking for dA dt. So the only thing now we need to find is dA dr, which is the rate of the radius. The area is changing with respect to the radius. So what will I do? First of all, I need to identify area of a circle. We know area of a circle is given by pi r what? Square. That is the area of a circle. Or let's say we can also write down the data from the question. I should be having the rate of change of this. So dr dt is given as 0.2 centimeter per what? Seconds. That is given. What again? The radius itself is given as 4 centimeter. So what else do we need? The only thing we need is to differentiate the a with respect to what? To r, so that we can come back to this formula. So from here, let's have our dA dr. Differentiation of a with respect to what? R. Don't forget pi is a constant. So 2 come forward to give you 2 pi. Then r, we subtract 1, give us r. So here our dA dt is what we are interested in. That will be beginning with dA, then the r will be dr, then dr over dt. Make sure that the r, the dr are in diagonal so that it will cancel to give you the A, the T if you were to cancel. So the left is equals to what? The right. So that means the A, the R, 2 pi R times the R, the T, which we have as what? 0.2. But don't forget, we need to eliminate the R. So R equals to 4 centimeter, making your dA dt to be equals to 2 pi times 4 times 0.2. I believe this will be 8, right? Then 8 times 0.2 means 2 out of 4, 10. And that will be 16 divided by 10. That will be 1.6. We're looking for area, so centimeter square per second. So the rate at which the area is what? Changing with respect to time is going to be 1.6 centimeter square per second. I believe the concept of rate of change has been grabbed, right? The next episode we take more questions to practice to see if we can be able to bring out the best out of rate of change. Subscribe to the channel on YouTube, follow us on Facebook, leave a comment. Please leave a comment and like the video after watching.